73 seconds after launch, the Challenger space shuttle rises higher and higher towards space. Its iconic white solid rocket boosters roar as flames spew out of the back of them. The flight crew has continued to communicate with launch control since liftoff. No one knows that anything is wrong and that in the next second, tragedy will strike. A fire rages along the side of the right booster as fuel escapes due to a compromised seal. In moments, the supporting struts connecting the rockets to the orange external fuel tank will experience a catastrophic failure. The booster will slam into the tank, rocket fuel will ignite, and there will be a massive explosion. April 4th, 1983. T-minus 2 years and 9 months until the Challenger disaster. All systems go, prepare for liftoff. Mission Control says over the intercom to the Challenger flight crew, this will be the space shuttle's maiden voyage. The boosters ignite, and the 184-foot, 4.5 million pound space shuttle thrusts towards space. The first mission was a success, and the Challenger space shuttle will end up flying 6 more missions that year. The shuttle is reliable, but every time it launches into space and lands after re-entry, a toll is taken on the spacecraft. Constant repairs need to be made while old components are swapped out for new ones. Engineers who work on the shuttle day in and day out warn NASA that the stresses that constant missions to space place on the space shuttle may lead to tragedy in the future. July 19, 1985, T-minus 6 months until the Challenger disaster. We're pleased to inform you that you've been selected to become the first teacher to go to space. Krista McAuliffe can't believe the words she's just read. Several months ago, she submitted her application to the NASA Teacher in Space project along with 11,000 other educators. Never in her wildest dreams did she believe she would be chosen. However, this letter confirms that she will in fact be going to space and that she will be lucky enough to share this incredible experience with students across the country when she gets back. McAuliffe teaches at Concord High School in New Hampshire. When she tells her colleagues the news, they are elated. Her family, friends, and students are all extremely happy for her. As a part of the Teacher in Space project, she will conduct 2 lessons from orbit and embark on a lecture series across the United States to share her experience with students. This will be done to highlight the importance of teachers in the country and hopefully inspire students to pursue careers in technology and science. Over the next several months, McAuliffe joins her fellow crewmates at Johnson Space Center in Houston, Texas, where they train and prepare for their coming mission. Francis R. Scobie will be the commander of the spacecraft. In April of 1984, he piloted Challenger mission STS-41C, which deployed a new satellite and repaired a damaged satellite before returning to Earth. Since then, he's been an instructor pilot for the Shuttle 747 carrier aircraft. This will be his first space command, and he couldn't be more excited. Piloting the mission will be Michael J. Smith. He's flown 28 different types of civilian and military aircraft and logged 4,867 hours of flight time. Judith A. Resnick will be one of the mission specialists on board. Resnick had become part of Astronaut Group 8, which was the first to include women on the team. She's developed a variety of software and procedures that are utilized throughout NASA. She's been to space before aboard the STS-41D mission in August 1984. This was the very first mission of the Space Shuttle Discovery. 2 other mission specialists are a part of the Challenger crew as well. Ronald E. McNair flew aboard Challenger in February 1984 during mission STS-41B. It was on this mission that he became the second African American to fly into space. Ellison S. Onizuka was the first Asian American and the first person of Japanese origin to reach space during his time aboard the Space Shuttle Discovery during STS-51C. The final crew member aboard the upcoming Challenger launch, designated STS-51L, is Gregory B. Jarvis. He's the payload specialist. This will be his first time in space, although he's been slated to fly aboard a different shuttle in April of 1985, but his spot was given to U.S. Senator Jake Garn instead. Then a similar situation happened again in early January 1986 when U.S. Representative Bill Nelson took his place aboard another space shuttle. Now Jarvis finally has the opportunity to reach space where he can put his astronaut training to good use. But like every other member of the crew, he will never actually make it beyond Earth's atmosphere. January 22, 1986, T-minus 6 days until the Challenger disaster. The Challenger crew eagerly awaits confirmation of whether their mission is a go or not. A high-ranking NASA officer enters the room with a frown on his face. "Sorry about this, crew, but we're gonna have to delay your mission until 61C gets back. Their assignment ran into delays, and their shuttle isn't due to land until tomorrow." The Challenger crew looks at one another in dismay. They're eager to get going. Every mission to space is special, and even for veteran astronauts, it's what they dream about doing every night. It's as if the stars are beckoning them to reach for the unknown. January 27, 1986. T-minus 1 day until the Challenger disaster. Challenger mission STS-51L is planned to have an early morning liftoff the following day. The astronauts toss and turn in their beds in anticipation. A chill sweeps across Florida as if foreshadowing the ominous events that'll happen in the coming hours. The launch pad becomes covered in thick ice. The metals that make up the space shuttle and boosters contract slightly with the cold. As engineers check the spacecraft over and over again to make sure it's in an acceptable condition for launch, a disturbing realization surfaces. "Sir, I want to reiterate that I'm concerned about the reliability of the seals in the rockets," an engineer explains to his supervisor. For over 2 years, the engineers and technicians that work in the shuttle program have warned that the space shuttles are being overused. The crafts are sturdy and well made, but every machine has its breaking point, and it feels as if after dozens of flights, it's only a matter of time before something tragic happens. The NASA official acknowledges the engineers' concern, but does nothing more. The launch will commence as scheduled, regardless of the warnings voiced by the men and women working directly with the spacecraft. January 28, 1986, 9 a.m. T-minus 2 hours and 38 minutes until the Challenger disaster. The sun is rising higher and higher over the Atlantic Ocean. A crowd gathers around Cape Canaveral to watch the launch at Kennedy Space Center scheduled for later that morning. There are members of the press, local residents, and people who have traveled from around the world to watch the launch. Many are there to witness the historic event of the first teacher to go to space. Excitement and anticipation fill the air. This will be the 25th Space Shuttle launch and the 10th Challenger mission. All other flights have been successful, so there's no reason to suspect today should be any different. The astronauts don their suits and proceed to their launch vehicle. They are greeted by cheers as they step off their transport and proceed toward the elevator that will carry them to the cockpit of the Challenger. Mission Control in Houston prepares to track and monitor the space shuttle's progress. Telemetry coming in from hundreds of sensors is recorded and double-checked to make sure that Challenger is ready. The astronauts strap in, and the shuttle door is sealed behind them. The cockpit is quiet except for the sounds of switches being engaged while Scobie and Smith check the systems on board. There's a sense of anxiousness, excitement, and pride as the 7-person crew prepares for launch. McAuliffe looks out the window directly ahead of her at the blue sky. Just beyond the atmosphere lies the edge of space. A bird flies past. McAuliffe smiles. Soon she'll be doing something that only a handful of people in all of history have done. She checks her safety harness and leans back in her seat, releasing a long sigh. Besides the crew, the shuttle also carries a tracking and data relay satellite designated TDRS-B. Also in the cargo bay is the Spartan Halley aircraft, which is designed to be released from Challenger to study Halley's comet for 2 days while the celestial object approaches the Sun. The small satellite will then be picked up by the Challenger crew and brought back to Earth so scientists can analyze the data it's collected. Tragically, no one and nothing aboard Challenger will survive to perform this series of tests. January 28, 1986, 11:38 a.m. T-minus 10 seconds until launch. Due to weather conditions, the launch has been delayed yet again. However, the atmosphere is beginning to cooperate. The sky clears up and the wind calms. Commander Scobie and Pilot Smith check their sensors and instruments one last time as they prepare for the rockets to fire. Mission Control reaches the end of its countdown. 10, 9, 8, 7, 6. We have main engine start. 4, 3, 2, 1. And liftoff. Moments before the engines ignite and the space shuttle rises, the solid rocket ignition command is sent. The boosters roar to life. The space shuttle and the Earth around the launch pad begin to shake. The sound travels across the water and reaches the bystanders watching the space shuttle launch from miles away. Astronaut Judy Resnick is heard over the intercom. "All right," she yells. Challenger space shuttle achieves liftoff. After the rockets ignite, 8 25-inch long, 7-inch wide exploding bolts fire. The Challenger space shuttle is free to rise into the sky. The deafening boom of the engines, massive amounts of smoke, and intense heat roll across the launch pad. A quarter of a second after launch, sensors record the first vertical motion of Challenger as it begins its ascent. Unknown to anyone on board or at Mission Control, an abnormal black smoke is seeping out of the right solid rocket booster near the location of one of the O-ring joints. This is the first sign that something is about to go terribly wrong. 1 second after liftoff. "Here we go," Pilot Michael Smith says over the intercom. As the space shuttle proceeds toward the heavens, the black smoke coming from the right rocket seems to be slowing down. 3 seconds after liftoff. Launch Commander Hugh Harris has just finished the countdown and pauses for a moment to watch. He announces on NASA Select Television, liftoff of the 25th Space Shuttle mission, and it has cleared the tower. The abnormal black smoke coming from the bottom of the solid rocket booster appears to have disappeared completely. 5 seconds after liftoff. All systems go. There are no anomalies detected by anyone at this point in the launch. The 3 liquid-fueled main engines on the back of the space shuttle are throttled up from 90% to 104% thrust. Everything is going according to plan. At Mission Control, Data Processing Systems Engineer A.F. Elgate confirms liftoff. There's a cheer in the room, then everyone immediately goes back to monitoring their stations. Suddenly, there's a data blackout from the space shuttle. No one panics. This is to be expected as the flames and structures around the launch complex interfere with the radio signals being sent to the antenna complex. But there is one piece of data that is slightly unnerving. I'm reading the internal pressure on the right side booster to be 11.8 pounds per square inch higher than normal, one of the technicians in Mission Control says. The rocket is still within acceptable parameters, but this initial data point will be used later on to identify when the Challenger space shuttle began to run into trouble. 8 seconds after liftoff. Once Challenger is in the open air, Pilot Smith begins a roll maneuver that puts the crew in a heads-down position so the top of the space shuttle is pointing toward the Earth and the bright orange external fuel tank is toward the sky. Houston, Challenger, roll program, Commander Scobie says over the intercom. Roger, roll Challenger. Astronaut Dick Covey says from Mission Control. Good roll, flight. Flight Dynamics Officer Brian Perry confirms from the control room. 19 seconds after liftoff. The Challenger space shuttle begins to shake. There's a sudden, violent thrust to the side. The crew grits their teeth as Michael Smith pulls on the flight stick slightly. With the help of the nav system, the space shuttle realigns itself and Challenger is back on course. Looks like we got a lot of wind here today, says Smith over the intercom. Commander Scobie confirms the assessment. They begin throttling down the 3 main engines of the space shuttle to 94% thrust as planned at this point in the flight. 21 seconds after liftoff. Challenger's roll maneuver is completed and all systems confirm it is on the proper trajectory to reach orbit. Commander Scobie looks out the cockpit window, hoping to get a glimpse of the land below. It's a little hard to see out my window here, he says. The engines continue to throttle down. 28 seconds after liftoff. There's 10,000 feet and Mach 0.5, Smith says over the intercom. Challenger is now traveling at half the speed of sound and is 10,000 feet above the surface of the planet. It's at this point that the space shuttle begins reaching the region of maximum aerodynamic pressure. Mission Control confirms that engines are throttling down to 94% and remind the flight crew that they will be throttling down to 65% thrust in a few seconds. 35 seconds after liftoff. Smith begins to throttle down the engine some more. All data indicates that the shuttle's computer systems are making the proper adjustments to deal with the wind shear. 5 seconds later, Smith confirms that they have reached Mach 1. Scobie adds they're passing 19,000 feet in altitude. 45 seconds after liftoff. There's a bright flash slightly behind the space shuttle's right wing. Moments later, there's a second bright flash. 48 seconds after liftoff. A third flash appears downstream of Challenger's right wing. The crew can't see these ominous explosions, but a 70mm tracking camera captures them as it zooms in on the shuttle for a close-up view. Everyone who is viewing the footage is baffled at what they're witnessing. Suddenly, an orange ball of flames erupts from under the right wing. This fireball is coming from the right booster. The Challenger crew and Mission Control have no idea that anything is wrong as the space shuttle's telemetry all reads nominal. The fireball from under the wing merges with the flames of the solid rocket boosters. 58 seconds after liftoff. Challenger accelerates past 1,539 miles per hour or 2,477 kilometers per hour. It has an altitude of 26,127 feet or 7,963.5 meters. Scobie gives the command to throttle the engines back as planned. Smith confirms the command. Mission Control confirms that the 3 engines of the space shuttle have all throttled down to 65% thrust. While this is happening, the tracking camera on the ground observes the first evidence that there is now something seriously wrong with the right solid rocket booster. An abnormal plume of smoke has begun pouring out of the rocket. The Challenger crew has no sensors in the cockpit that display the performance of the solid rocket boosters, and therefore are unaware that they are in serious danger. A second later, Challenger passes through the region of maximum aerodynamic pressure, which pushes against the space shuttle and its boosters with 720 pounds of pressure per square foot, or 7,750 pounds per square meter. The plume of smoke coming from the side of the booster intensifies. Inside the booster itself, an O-ring has disintegrated, the very same component that engineers at NASA were warning would fail if the space shuttle launches were not dialed back. The O-ring on the booster was meant to seal the joints between separate parts of the rocket and prevent the leaking of fluids and gases from one chamber to another, With the O-ring destroyed, fuel is making its way through the booster and igniting due to the intense heat of the flames. A continuous inferno is expelled from the right booster along the side furthest away from the space shuttle. The windows in the cockpit give Scobie and Smith limited visibility, and they're not able to see the fire from the shuttle. 60 seconds after liftoff. "Feel that mother go!" Smith says over the intercom. Another member of the crew is heard yelling with joy in the background. At that moment, Mission Control receives data that indicates the internal pressure in the right side solid rocket booster has begun to drop. It's not known at the time, but this severe drop in pressure is the result of the hole created by the ignited fuel spewing out the side of the rocket where the O-ring has failed. The flames pouring out of the side of the rocket begin to lick the fitting attachments that couple the back end of the booster to the external fuel tank on the underside of the space shuttle. This starts to degrade the integrity of the couplings. 62 seconds after liftoff. Challenger shudders once again from high wind speeds. The shuttle rolls slightly to compensate as it passes 35,000 feet and approaches Mach 1.5. The wind is worse than predicted and stronger than any of the previous 24 shuttle missions. However, it's still within acceptable limits, even if it puts slightly more stress on the shuttle. 64 seconds after liftoff. The flame in the right side booster changes shape suddenly as the heat from the fire melts through metal plating, and liquid hydrogen begins to fuel the fire. The glow on the outside of the booster intensifies. As the force of the raging fire builds up, it begins to move the engine nozzle in large arcs. This momentum begins to shift the space shuttle's course, which the computer then adjusts for. The right booster's thrust levels are thrown off due to the leaking fuel and fire burning on the side. However, the nav system manages to compensate. Tremors vibrate through the cockpit as the hydrogen fuel is ignited, but get lost in the turbulence experienced due to the massive acceleration and wind shear. 66 seconds after liftoff. "Throttle up, 3 at 104, Mission Control says over the comm. Houston and the Challenger flight crew are all still unaware of the fire coming out of the middle of the right booster, and other than a drop in pressure, there's no indication that there is a serious problem. The fire outside of the shuttle spread further. The flames creep toward the belly of the shuttle, where the external liquid hydrogen tank is located. The pressure inside the fuel tank suddenly begins to drop, indicating that an alarming amount of liquid hydrogen is leaking out. The fuel tank gauge plummets inside the cockpit, but Smith and Scobie don't notice it as they're focused on throttling up the engines and preparing to disengage the boosters. Even if either crew member was looking at the fuel gauge, the rapid dropping of pressure happened so quickly that there was nothing they could have done. The fuel tank can only be disengaged when all other engines are turned off, and the shuttle is in a benign aerodynamic environment higher up in the atmosphere. If they had disengaged the fuel tank to get away from the leak at this stage, the Challenger would have been forced into the fuel tank and the still burning solid rocket booster exhaust. 68 seconds after liftoff. The fire spewing from the side of the rocket connects to the exhaust plume. The liquid oxygen propellant being fed into the main engines of the space shuttle falls drastically. Smith continues to throttle up the engines to reach 104% thrust. 72 seconds after liftoff. The back end of the right booster is ripped away from the external fuel tank. The strut that had been securing it has been compromised and failed. The back end of the right booster is now moving up and down relative to the space shuttle and fuel tank. Another explosion, likely from the stress and leaking fuel, occurs higher up on the booster near Challenger's cabin. The flame near the top of the booster grows rapidly, creating an enormous fireball. The nozzles of the engines on the back of the space shuttle begin moving at a rate of 5 feet per second in order to compensate for the unhinged booster. The top of the right booster is still connected to the fuel tank, but the loose back end causes a burst of lateral acceleration that jerks the shuttle. The main engine pressure decreases. Engine nozzle motion rates are off the chart. Things are very, very bad. Challenger sends its final navigation update. 73 seconds after liftoff. "Uh-oh," Smith says. These will be the last words uttered over the comms by any of the Challenger crew. It's not clear what Smith is referring to, but it's likely that several sensors begin showing clear signs that something is wrong. The fuel tank and loose booster begin breaking apart. The shuttle jerks the opposite way it had moments before. The right booster is now producing 100,000 pounds of thrust less than the left booster. The unbalanced acceleration begins forcing the right booster up into the liquid oxygen section of the external fuel tank. Liquid hydrogen and oxygen begin leaking out of the external tank. A cloud of fuel accumulates outside. The right booster pushes further into the fuel tank and increases the amount of liquid oxygen being expelled. Milliseconds later, the inevitable happens. There's a bright flash of light located between the Challenger shuttle and the external fuel tank. The leaking fuel has been ignited. The fireball engulfs the space shuttle. There's a crackling sound over the intercom as ground transmitters search for a signal that is no longer there. Another explosion occurs near the front of the external fuel tank. This ignites the remainder of the fuel inside the front section of the tank, causing it to detonate. Challenger's engines redline and the computer initiates an emergency shutdown. Main engine 3 goes first, followed by number 1. The last telemetry signal from the space shuttle is sent while it is being torn apart. 74 seconds after liftoff, the radio signal from Challenger goes silent. Another explosion occurs near the space shuttle's nose. The cockpit with all 7 members of the crew is engulfed in flames as the rocket fuel in the forward reaction control system ignites. The debris of the destroyed shuttle continues traveling upward at Mach 1.92, or approximately twice the speed of sound. It reaches an altitude of 46,000 feet or 14,021 meters. Challenger's tail emerges from the fireball around the same moment that a wing can be seen. The fuselage and payload bay are torn apart by the rush of air forced in from the tail being ripped off, overpressurizing the payload bay and breaking it apart from the inside out. Wires and electrical cables flail behind the fuselage like tentacles. The satellites in the cargo bay are ejected into the air. The crew cabin arcs out of the flames and smoke. It seems to be intact, although there's a gaping hole where it used to be connected to the rest of the shuttle. Some of the crew may still be alive and awake, but when the Challenger is ripped apart, all of the air is sucked out of the cockpit, and a dramatic pressure drop results in everyone passing out. For this mission, the astronauts did not wear pressurized suits during liftoff. As they slump in their seats unconscious, oxygen deprivation settles in. Any crew member who is still alive will suffocate within the next few minutes. The 2 solid rocket boosters continue to fly upward at different angles, now free from the struts that connected them to the external fuel tank. 1 second after the Challenger space shuttle explodes. Mission Control does not yet know that the Challenger space shuttle has exploded. 1 minute 15 seconds, velocity 2,900 feet per second, altitude 9 nautical miles, downrange distance 7 nautical miles, says Stephen Nesbitt, the public affairs officer at Mission Control. 2 seconds after the Challenger space shuttle explodes. A parachute emerges from the carnage, giving people hope, but as the tracking camera focuses, it turns out to be the nose cap of the right solid rocket booster. Smoke and flaming debris arc outward from the blast. The rocket boosters continue to fly upward, leaving a corkscrew trail of smoke behind them. 15 seconds after the Challenger space shuttle explodes. Flight GC, we've had negative contact, loss of downlink, says the ground control engineer N.R. Talbot. It's at this point that Mission Control is aware something tragic has happened and is trying to figure out exactly what happened. They're informed that the Challenger space shuttle has been lost. 36 seconds after the Challenger space shuttle explodes, a self-destruct signal is sent to the rogue solid rocket boosters, triggering an emergency detonation. Both rockets explode in a plume of black smoke. Debris falls back toward the Earth. Without the weight of the space shuttle and the fuel tank, there was no telling how far the rockets would have gone before burning the last of their fuel. They needed to be detonated to eliminate the risk of them crashing back to Earth in a populated area rather than the desolate waters of the Atlantic Ocean. 1 minute and 31 seconds after the Challenger space shuttle explodes. Multiple sources have now confirmed that the Challenger STS-51L has been lost. Rescue efforts are launched. 2 minutes and 11 seconds after the Challenger space shuttle explodes. The TV tracking camera spots the first pieces of the space shuttle crashing into the ocean. 33 seconds later, the crew cabin slams into the waves of the Atlantic at approximately 200 miles per hour or 322 kilometers per hour, at a braking force 200 times that of normal gravity. The crew cabin disintegrates on impact and sinks 100 feet to the bottom of the ocean. For the next few minutes, debris continues to splash down into the ocean east of Patrick Air Force Base. A cloud of brown smoke lingers over the surface of the water as a result of the hydrazine rocket fuel that covered the wreckage as it entered the ocean. Mission Control pinpoints the crash site as being approximately 28.64 degrees north at 80.28 degrees west, 5 minutes after the Challenger space shuttle explodes. The broadcast on NASA television has been eerily quiet as everyone tries to take in what just happened. The camera view switches from the ocean back to the grandstand at the press site. Observers stand with their backs to the camera, looking up at the sky where a white cloud of smoke still lingers. White wisps of haze extend from the explosion site, like weeping willow vines indicating where burning debris fell from the sky. 8 minutes and 5 seconds after the Challenger space shuttle explodes. This is Mission Control, Houston. We are coordinating with recovery forces in the field. Range safety equipment, recovery vehicles intended for the recovery of the SRBs in the general area, says Stephen Nesbitt in a somber voice. The only thing left to do is go through the data, recover as much of the space shuttle as possible, and determine what caused the horrific accident that led to the loss of 7 people aboard the Challenger space shuttle. March 7, 1986, 1 month and 10 days after the Challenger space shuttle disaster. The USS Preserver bobs up and down in the dark waters of the Atlantic Ocean. A dive team has just been deployed to scout the hypothesized location of the Challenger cabin. The divers locate the wreckage that was in the front of the space shuttle and confirm that the bodies of the crew are still inside. The aftermath of the Challenger space shuttle disaster. All space shuttles are immediately grounded, and any upcoming launches are canceled, pending a full investigation of what happened to the Challenger. NASA and a group of men appointed by President Ronald Reagan, known as the Rogers Commission, began looking into the chain of events that led to the loss of the space shuttle and its crew. It's concluded that the space shuttles are being pushed too hard, and the concerns of engineers working on the crafts are being ignored or overlooked. What it came down to was that NASA had been trying to accomplish too much with too little funding. The investigation also determines that the 2 rubber O-rings which led to the fuel leak in the right booster and eventual catastrophic explosion of the external fuel tank were compromised by the severe cold from the night before the launch. Unfortunately, even if the crew had been aware of the problem at liftoff, there would have been no way for them to avoid the disastrous consequences. The space shuttle wouldn't have been able to survive a high-speed separation, even if it was attempted before the external fuel tank exploded. On June 6, the report is given to the President, who determines Marshall Space Flight Center in Huntsville, Alabama, Morton Thiokol Inc., and NASA as a whole are responsible for the Challenger disaster. Marshall Space Flight Center constructed the shuttle boosters, engines, and tank, while Morton Thiokol manufactured and built the booster motors. It's also uncovered during the investigation from several engineers who testify that they expressed concerns specifically about the O-rings and their seals to their supervisors for at least 2 years prior to the loss of the Challenger. The Rogers Commission recommends that communication between engineers and NASA management be tightened, quality control procedures be improved, and several more checkpoints be added to the Shuttle Safety Advisory Panel. On September 29, 1988, the Space Shuttle Discovery launches with 5 veteran astronauts on board. This is the first mission since the Challenger disaster. The Space Shuttle program lasts for 23 more years. On July 8, 2011, Atlantis launches from Cape Canaveral. It will be the 135th Space Shuttle mission. Atlantis lands on July 21, 2011, marking the official end of the Space Shuttle era. 2 space shuttles were lost during the 30 years that they were in use. On February 1, 2003, Space Shuttle Columbia disintegrated as it re-entered the atmosphere. And on January 28, 1986, Challenger exploded due to a faulty O-ring. Both crafts had a crew of 7, all of which were lost, and all of which were heroes. Now watch Atomic Bombing of Hiroshima and Nagasaki Minute by Minute, or check out What if the USA launched a nuclear bomb minute by minute.